Welcome, everyone. My name is Chris Paoli, editor, and I am pleased to be moderating our first session as well as welcoming you to today's Multi-Cloud and Hybrid Cloud Data Summit, brought to you by Red Hat, CoreView, and Cloudera. The editorial staff of Virtualization and Cloud Review have worked hard to bring together some of the best independent experts on the topic for this event, so we really hope you enjoy it. Before we start today's event with these three great sessions, we do have some announcements. First, we wanted to let you know that this event is being recorded and will be available for future viewing. You'll receive an email when this replay is available, generally within the next few days. Each of today's three sessions will be followed by a 5 to 10 minute Q&A, so please be sure to put your questions into the Q&A area of your console as they come up. During today's third session, we will be giving away a pair of Ray-Ban smart glasses, but you must be present to win. So be sure to stay on for the entire event. Finally, we do have resources from our sponsors, Red Hat, CoreView, and Cloudera, available on the console right now. So please download and check those out. It's because of their underwriting of this content that we can bring you the summit, so we thank them for sponsoring this and then supporting the community, and ask you to check out these resources so we can bring you more great events in the future. Now on to the first session of today's summit, Top Data Best Practices for Hybrid Multi-Cloud. This session features Karen Lopez, data evangelist for Info Advisors, space enthusiast, and NASA Datanaut. Karen is a senior project manager and architect with an extensive background in development processes and information management. She specializes in taking practical approaches to system development and has 20-plus years of public speaking. She wants attendees to have fun, gain insights, and take away inspiration for working with new technologies and methods. She's known for her slightly irreverent and practical approach to IT training and speaking. Take it away, Karen.
Thanks so much. I am really looking forward to sharing these thoughts with all of you today. And as we've talked about, as Chris talked about, this event has sponsors. I always appreciate sponsors all the time for making these things happen. He did a great introduction for me, and the title I use, Data Evangelist, is because I never know for sure what title to give when you're a single-person company. But I'd like to invite you to continue this discussion even now on Twitter. My handle on Twitter is DataChick. I'd also like to friend you or link with you on LinkedIn, and if you mention that we met here, I'm more likely to process that friend request as soon as possible. That's the abstract for this. Just a little bit of logistics here. You can ask questions anytime in the Q&A. Don't save them up for the end. I've told Chris, if he gets a great question, feel free to interrupt and ask the question when we're on the slide that that's about. I also appreciate if you have comments or light stories. I know that's not really Q&A, but I'd love to see the audience sharing what they've learned about some of these things. And of course, if you share any stories, our team rule here is that they're always about something you heard about another organization. So let's get started into this. My style is a little bit about having some fun, being a little snarky or irreverent at times. I think for a short session like this, if you learn about three things, I consider that successful, even if it's one of my terrible dad jokes that I like to tell. So before we start on this, I was thinking about this topic. Last week, I attended an analyst briefing for a bunch of cloud-related vendors where they were telling us about their new products or new solutions that they're offering. And one of the things we kept running into is that people didn't have, common terms. Of course, a data person is going to tell you this, that having common terms is really important to sharing information and making decisions. So I'm just going to define a couple of terms. Then I'm going to talk about how do data practices vary versus whether you're only on-prem, whether you're hybrid cloud or multi-cloud, and then what things are, the answer is it just depends. And then I'm going to wrap it up like I do with most of my presentations, 10 tips for getting this right. So let's start with the definition for multi-cloud. The way I'm going to use it here is that you are using services or resources from more than one cloud vendor. Those services are usually things like platform as a service, infrastructure as a service, could be software as a service, and a new term that came up I'm going to show you on another slide coming up. It can also mean that you architect your full application things in containers like Kubernetes so that you can port your application and all the resources it needs on-prem, in this cloud, in that cloud, on this environment, and that environment. So this isn't everyone's definition of multi-cloud, but I think this is probably the most common one. The next is hybrid cloud. Now this is where people get a bit confused. The common definition in hybrid cloud is that you use some on-premises resources, but you also use one or more clouds or cloud vendors in your solutions. Notice that that means that you can be multi-cloud, hybrid cloud, or hybrid multi-cloud or multi-hybrid cloud, depending on how all these things are mixed together. And of course, hybrid cloud could also include containers using things like Kubernetes or Docker to deploy your solution. Now, the reason I make these distinctions here is I'm thinking back, like even as recent as 5 years ago, the word on the street was, we're never going to do multi-cloud. It makes no sense. It makes things more complex. It's hard to manage. And we've gotten to the point now where almost every organization of a decent size of complexity is multi-cloud, sometimes for very good reasons, sometimes because everyone was just allowed to work in whatever cloud they felt comfortable with. The other thing is I think that almost all organizations, unless they have regulatory or compliance issues, which would be really rare, are hybrid cloud at this point. Now, I'm going to leave out someone who's just a software company that builds software as a service. They could be 100% cloud in their solution, but I'm talking about enterprises and organizations that aren't just cloud providers or service providers. I think pretty much everyone's hybrid cloud now. The only thing they do is put backups into cloud storage so that they can meet their 3-2-1 obligation of having backups off-site. Now, also, there are some different terms for what we call a cloud provider. So today, when I say a cloud provider or vendor, I'm talking about, any cloud provider, but basically Azure, AWS, Google Cloud, any of these cloud providers, people who are in the business of providing cloud solutions. And a cloud provider themselves, sometimes, so I do a lot of work in the data center world, and a lot of times the terminology they use is hypervisor, and they really mean Azure, AWS, Google, Oracle Cloud, one of them. And that's a term that carries over from virtual machine and virtualization. I only ever run into this with storage and infrastructure people, but I just wanted to mention that that's sometimes the terms that we use. A cloud provider could be a single tenant, such as someone who stood up their own private cloud, or someone who's running cloud services but on-prem, such as through an appliance or through their own architected private cloud offerings. It could be multi-tenant. So most public cloud providers that you think of, the Azure, AWS, are multi-tenant, and there can be clouds within clouds. So what do I mean by that? So I'll use the example from Azure. Azure Cloud is not just one thing. There's the public or commercial cloud that we're most familiar with. There's Azure Government, which is configured and constrained in ways to make that cloud offering meet government, specifically U.S. government, but all kinds of government regulations and strategies. Then there's also Azure Germany, which is solely, it maintains in those services solely in Germany, as well as Azure China. So those are clouds within clouds. They're really four separate, physically separate clouds. Of course, they can talk to each other, but there are limitations and regulations about how these other clouds participate with the public cloud. So let's talk first about what's the same about data management and data practices, whether or not you're on-prem, hybrid, or multi-cloud. So this is a giveaway for someone who uses the title data evangelist. I think data is everything, and everything is data. So when I say that, it's not just me seeing the whole world through a data lens. It's really about things that we don't think of as data. I do think of it. So for instance, your JSON file that holds the configuration for the VM that you've deployed, that's data to me. It's just IT data. If you build out a software-defined storage system, the software definition is important, but it also includes data. And people forget that system data is just IT's data. It's our enterprise data. So I think it's important when I'm talking about the top data practices in hybrid cloud and multi-cloud, that we all remember that that data is data that needs to be loved as well. So something that's the same. Business requirements should be the driver for all design decisions. And my mantra is you should be able to explain the costs, benefits, and risks of any solution and any solution alternative. And we do this naturally, but we tend to focus on just the benefits. Like I happen to do this in real life, I happen to do it on my project, but I have to remember that the cost is not just the price tag that's on a service or on that amazing lunch I want to have, it's the total cost. And we sometimes, as technicians and engineers, forget there's a total cost involved in change, and we're going to talk about that. Any solution we build should be built to whatever compliance and regulatory constraints we have. We should always be talking about security and privacy, and there's a bunch of other areas in data management that we need to focus on, but these are the primary ones I speak to. I also think that data architecture goals, no matter where you're building out your data, we should build for flexibility and build in so that they can be changed, especially as we move into cloud things. So for instance, the ability to scale out very quickly and scale back in, that's a design configuration that also impacts some of our data decisions. We should build systems to be resilient, that's both to be highly available as well as resilient against failure or hacking or ransomware or those things. And we should always build our data architectures to have the right quality. Notice I didn't say high quality or perfect quality, but the right quality for those data needs. I also think data protection is just as important regardless of where you're deploying systems, but in order to protect the data, we need to make sure that we have inventoried and measured our data. And one of the things I've noticed, especially as organizations move into deploying cloud services, and especially when they get to multi-cloud, is we kind of lose track of what data is where and what protections it has. So, someone's setting up a machine learning environment and they, imported a bunch of photos of people and objects, and we're going to build this machine learning to recognize photos that customers have submitted of a broken item that they want to return, as an example. And we want to use AI and ML to try to determine what that item is and where it's broken. Very common, sort of easy use case these days to do that. But maybe they set up their machine learning environment in a different cloud because that's what they worked with on their last project, and they were able to do this as a proof of concept. Well, now we've moved a bunch of customer-owned data into another cloud. Who's going to know about this? Who's going to keep track of where we've moved that data? So data governance is still an issue and still the same no matter what type of architecture we're using. Categorization is also something that is becoming newer both on-prem and in the cloud. That is where you're identifying not just the types of data everywhere, but every data fact gets classified about whether it's sensitive information, personally identifiable information, financial, and we keep those categories somewhere, usually in a data catalog or in a repository, so that we can also check those tags to see if it's permissible to move this data into this country or permissible to put it on a customer-facing site. The other part of data protection that's so important is, of course, backup and recovery. But I say this as if it isn't obvious, but there are some software as a service solutions where, of course, you don't get to back it up. Your software as a service provider does those backups. And I recently worked with a client at another company who started asking about backups and how do we go about getting a restore. And the answer we got from the software providers, oh, we don't have to worry about that because we have high availability. And most of you out there would totally recognize that high availability is not the same as disaster recovery. So we pushed back and we said, no, but you must be doing backups. And they said, of course we're doing backups. Okay, if we accidentally update all of our customer records because we screwed up a filter, how do we get that restored? And the answer that came back is, oh, we wouldn't restore backups for that. We would get a developer in to help you fix the data. And that said to me that we are probably in a multi-tenant situation where they do backups for catastrophic failures, but not user error type failures, where the data has been incorrectly updated or inserted or duplicated or deleted through a normal business process. And that said to me is that they're probably not meeting our posted backup and recovery policies. So that's something we're going to have to look at. No one thought to evaluate the software as a service vendor and their product for how they restore. All they asked is, do you do backups? And they said, of course we do. And now we find out, yeah, they do backups, but we're probably never going to be able to use them for a restore for anything other than if they have a hard drive failure or their HA doesn't deploy. The other thing is about that is the same no matter what you do, is that can you recover to a specific state of data? So for instance, this software provider told us that they do full backups once a week and incremental backups every day. Well, for our system, that's probably okay, but there are plenty of systems out there where losing a full 24 hours or a full week of data just is not the right restore point objective. So let's talk about what things are different between on-prem only and hybrid and multi-cloud. So I decided to break these down into the 5 whys plus how much for cost. So let's talk about the who. One of the things I've noticed as I work with cloud architects is that if I'm working on a team that has been totally on-prem for the lifetime of their career, that they're suddenly overwhelmed with so many options. So think about, if you've ever worked on a project, like, I don't know if you're experienced like I am and worked on projects before we even had the internet. So we had total control over our own environments. They were locally owned and managed, and I think our data center was even in our same building. We were really limited to what we had to learn about because we only had to learn about what we had on-prem. Now, when you want to move a solution to the cloud and you want to do some analytics on that data, and you're kind of sitting there with tens of thousands of options available to them. So for who, I think the best people to work with data on hybrid and multi-cloud environments is that they understand that there's this huge opportunity to build new skills, but that's both a cost and a benefit. So how are they going to be provided the time to build up their skills? How are they going to know what skills they need to build? How are they going to measure like how portable a skill is, say, in Bash to learning PowerShell or Python? And I think also given the potential for just extreme complexity when you go to hybrid and multi-cloud means that you'll want people who have a very professional work style. And I'm contrasting that with what I used to call the cowboy developer. So someone who was totally in charge of their total environment. He was the senior developer or she was the senior developer, and now is going to have to collaborate with all kinds of people. Quite often, people who are used to working and have sysadmin access to everything they have to work with, all of a sudden is going to get dropped in a world where maybe they don't need to have global admin access to every system that's being deployed. There's also this concept I'm going to bring up a couple times here, cloud fanatics. And I really do mean fans of certain cloud providers or people who are fans, not fans at all of certain vendors. These are people who are difficult to work with in a cloud system that they're not a fan of, or they resist working, say, with Oracle or Microsoft or Google. Whatever the reason, if you have someone on your team and you're migrating services to the cloud, if that person has really strong beliefs of rightness and wrongness with a certain cloud service or provider, that's going to get in the way of being successful in your solutions. Same thing I talked about with controlling style. And I bring this one up specifically to both multi and hybrid cloud. So if you're a DBA in SQL Server and you are the queen of tuning every little thing, file sizes, file locations, hard drive requirements, server build requirements, you're going to have a hard time working in cloud-provided compute because quite often you don't have access. Like if you're going from SQL Server on-prem to Azure SQL DB, which is Microsoft's database as a service that is pretty much feature for feature the same as SQL Server, it's just cloud-based, you don't have access to what the file system is, you don't have access to the backups, you don't have access to tune every little thing, to stripe your data across 12 file stores. If you're used to performance tuning by controlling all those things, you're going to have a hard time in software as a service environments. And then the last thing is open-mindedness, which is kind of the opposite of the fanatics thing, is that if you have people on your team who are working on the data side, but they are only relational database, and the cloud's going to offer them now a nearly infinite number of NoSQL solutions, if they refuse to do it because relational is good and everything else is bad, you're going to have a hard time being successful in a hybrid or multi-cloud environment. And I'd love to hear from you if you've ever heard of at another company someone who had to try to work in cloud solutions who had these differences that couldn't be overcome. The other thing that's interesting about working with data in the cloud is that I kind of made up this graph where I put people along whether their day-to-day job is supporting data stuff or using data. So I like to call all of us data professionals, and I'll just include you on team data here because you're attending something about data, is that, you know, we're a database administrator, but they rarely use the data in the database or touch it. The same thing for infrastructure people, the same thing for a data modeler, database designer. And then you start going through data architect, data steward, data scientist, data miner, data modeler, analytics, is that it's important that we understand as we make these moves to hybrid cloud and multi-cloud that not all the data people have the same point of view about the actual data, even though all these people would claim that they do data management. So I talked about software as a service, platform as a service, infrastructure as a service, databases as a service, networks as a service, and this one new term that came up last week in my analyst briefing is code as a service. That's just something that is interesting, but I just wanted to expose to you a new acronym here. Most of the uses in the cloud fall under these things. There's probably other things we could add in here, like Azure Active Directory. Well, technically, software as a service, it's also identity as a service. We'll just hear a lot of those things. So I typically, when I was a traditional data architect, wasn't involved in any platform management or infrastructure management. But now I've been drawn into this mostly because I'm helping make a decision in choosing these things, because we can change it up so quickly compared to buying servers and getting them deployed. Is if something's not performing well, I can make a recommendation that we scale up our server or distribute across more compute. I didn't used to have any access to those decisions, and in hybrid and multi-cloud, I have more input there. And I brought up this thing where we use the term software-defined storage, software-defined network. That also produces a lot of data. It's just IT data. That's configuration, the desired state, which says, I built this database. I want it to stay like this, and if it changes for somebody who did an unplanned change, I want to roll it back to where it was before so they can go through the normal process. You can do this on-prem for sure, but most modern cloud solutions have desired states in some form built into them. So the answer for when things are different. So the timing for when to go from totally on-prem to hybrid or multi-cloud or both, typically this happens when a new project is started or a new solution. Another time that's happened to me is when the system that we built this old solution on, all the software was no longer under support. I think it used a DBMS technology that was no longer support. It used a server OS that was no longer in support, and it used a web framework no longer supported. So we had to make this change, and we chose to go to cloud solutions, a hybrid cloud solution for that. This can also come about because of brand new compliance or regulatory pressures, which also usually leads to a new project or a project to alter things. It could be a new cost model. So there are stories out there of people realizing that some of the things that they manage on-prem might pay for itself if they moved it to cloud, that we could turn it on when we use it and turn it off when we're not using it. And therefore, we have variable workloads that we can save money by not having to pay for infrastructure we're not using. But the other thing that can happen is that the cost model on the cloud service can become so expensive for the workloads we're throwing at it that it might be moved back to on-prem. And people forget to talk about that, especially cloud fanatics like me, that we have to be constantly doing that cost, benefit, and risk assessment. New staff can come on, especially contractors and consultants like me, who say, why are you doing this on-prem? Like, we could get twice as much horsepower, we could meet our holiday shopping needs, Blippi workloads, if we went to a cloud architecture, and especially if we went to one that is using the same technology that we're using on-prem, but now we can have bursts in our workloads without failing everybody on our sales system. The other time this happens is a new company, meaning your company's been acquired or you've acquired a new company, is a common time for organizations to make a move to hybrid or multi-cloud. Or, my favorite one, someone read a blog post somewhere. So it used to be called the airline magazine problem, where an executive would read about some nifty new software in an airline magazine and then come back and say we have to have it because our competitor has it. Now that's reduced to somebody read a blog post that said this is the way we should be handling our data. So that's a little bit of my smart there. Where you do these things. So one of the things that becomes new in hybrid and multi-cloud is data sovereignty. That is typically done as data must stay within these borders. Either, for instance, here in Canada, we try to keep customer data in Canada, but not so much in the US because it becomes subject to certain laws there. But the other thing is there's no guarantee when you implement a cloud solution that all of the data always stays in a certain location. And that has to do with a few things. It has to do with you might intentionally have availability and failover to other regions in case of major outages, or you might be using a technology like Azure Active Directory, which forces some data into other countries because of the nature of how an infrastructure service is provided. Now, the exception is I talked about cloud within a cloud. So if you implement in Azure Germany, your data can't move unless you intentionally move it out of Germany. There may be compliance or legal or regulatory things that cause you to need to move data out of on-prem into a cloud service so that you have mandated availability of the data, or so because you've been regulated to now share this data with millions of people instead of your 100 employees, and the cloud makes a perfect sense for that. The other thing that people forget about when deploying in the cloud is that you can't out-engineer physics. So choosing the location of where your data is going to be could just cause it to perform slower because it's on the other side of the planet and you can't performance tune that distance away, or because your connection to the internet is too narrow. That's what I call pipes. And then, of course, the cloud within a cloud thing of choosing the right type of cloud when you do those things. That's the where, the why. So there's a whole lot of whys. I decided to pick the ones that I get the most questions about. So the why to use hybrid or multi-cloud is maybe you've not been able to meet some standard for security because your data center doesn't need it, or you don't have the right tools, or you don't have the right resources. So some security services can help you meet security and compliance requirements. Another reason to choose hybrid, multi-cloud, or on-prem is this concept of capital expenses versus operational expenses. And it used to be early on in the cloud, all cloud services were operational expenses, and almost everything you did on-prem because you had to buy it was a capital expenditure. Nowadays, there's ways of reserving compute and resources in the cloud to convert that operational expense to capital expense. And there are ways through the business models themselves of managing that at a much more granular level. Where this really makes a big difference is capital expenses and operational expenses are reported differently in accounting. Shareholders feel differently about it. And then there are some regulated industries where operational expenses can go into your cost basis. Capital expenses can, but operational can't. Like for some organizations, CapEx and OpEx is a big difference. So why on the skill set? So if you've been traditionally all-prem, maybe just some light hybrid use like backing up files to the cloud, making a move to go to hybrid cloud as a major part of your architecture is going to have an impact on the resources, the human resources that you have. So training and or acquisition of people with different skill sets, big difference on why you make a decision to do things. Workload variances, definitely. The more blippy your workloads is, the more you'll want to embrace scalability, especially scaling out, as well as how much redundancy and distribution you want for your data. There's some really good reasons to have the same data deployed in different places on the planet if you're a global organization, and that's that physics problem. Now, in the olden days, when I worked on only transactional systems, we didn't like moving data around because it was never quite in sync. It We had to use replication. It didn't always work. What happened if it replicated to one place but not the other place? Now you've got users getting different data in an untransactional system. That's practically blasphemy. But in a non-transactional system, that's also not only tolerated but sometimes embraced. Availability, I found with most of my clients that they have greater availability since they've moved certain workloads to the cloud because they don't have to buy 15 storage units or 15 servers. They can just use services that provide this high availability. And indeed, the high availability is often built into the architecture of a service you buy. Distribution of data and the location of data for sovereignty purposes is really important. How much? So one of the things I had the most fun and the most struggles with thinking about when I first started moving workloads to the cloud is that, how ingress, entering data into a system, is typically free in cloud services, but egress, taking it back out, has a price. I wasn't used to accounting for data movement in my costs because if we totally owned all the resources where our data was, it was already paid for. So there was no billing at taking data out of a database. But now in the cloud, I feel as if between storage costs in the cloud, again, storage on-prem, typically paid for all up front as a capital expenditure, but storage in the cloud is paid for per bit per hour or something like that. It can be really cheap, but it all adds up. I feel as if we data architects have gone from having unlimited long-distance calling to now paying for the minute for every call we make. And that's kind of funny if you're old enough to remember when things were like that, is that now we do have to manage data capacity and do capacity planning when we're doing our cost benefitness. The other thing is compute. I love that I can log into Azure and spin up a 60-node data warehouse. I love that. Doesn't even take that long. Would never have gotten that approved at any client for me to be able to do that. But it's super expensive because compute is expensive. Online compute is expensive. So it's really easy to even be playing with cloud services and all of a sudden realize you've run up a $5,000 bill just while you were playing with something. So I love all the opportunities in hybrid cloud and multi-cloud, but the compute is expensive, and so managing costs is so much different in the services-based model. I love that I can kick up performance on something even before we figure out what the problem is. We can add some more compute to it to solve the problem for now and then worry about going in and fixing it. I think HAMDR is much better in cloud. And this is also one of the major reasons why data people consider doing multi-cloud. This is one reason to do it. So if you have data both in Azure and Oracle Cloud, then if Azure has an outage, like it's had a couple of times in the past, we could just fail over into an Oracle Cloud. Now, it's not quite that magical, though, to do multi-cloud in a very smooth transition, but it's better than being down for 3 days or something, or down because your sysadmin walked off with the credentials because it wasn't architected correctly for permissions, and you can't get into the database anymore. Now, the second part of how much, these are things that people, like all the other things we talked about, you could go into a cloud calculator and figure out how much is it going to cost for me to move my 1 petabyte data warehouse from on-prem into a cloud provider or into several cloud providers. But these are the costs that technicians and engineers tend to forget about these things, is that the skill sets are different. I'm just going to keep saying that one. I personally enjoy that because I like learning new skills, but not everyone has time in their current workloads to do that. I also, because I work with database systems, have to make sure that the tools I'm used to using, literally tools I've used for more than a decade, will work with a cloud-based solution and we'll work with whatever DBMS we've chosen for that product. Because again, if we had a site license for Oracle, we didn't consider using 12 other DBMSs. But in the cloud, because licenses tend to come with the service, you pay for it as part of the service, it's really common to have DBMS bloat in hybrid and multi-cloud situations. Your processes could be different. Your techniques as you deploy things will be different. Your monitoring and alerting systems will be different. You may have templates that you've used in the past for deploying VMs that now have to be upgraded to work in the cloud VM infrastructure. A lot of these costs, which are hard to calculate, hard to measure, are some of the biggest obstacles to moving from a totally on-prem to a hybrid cloud or hybrid multi-cloud solution. So I said I was going to talk about it depends. Well, here it is. The it depends thing applies to everything I just talked about. So I kind of cheated on this, but I kind of said these are differences, these are the same. But everything you decide to do comes down to cost, benefit, and risk. How much time is it going to take? What are my compliance and regulatory environment? And what is the culture of the people on my teams? I think that's a really important thing to realize is the universal consultant's answer is always the universal answer. It depends. So let's work through these 10 tips. This is the most important one for data professionals, architect with a purpose. So I mentioned that, even as recently as 5 years ago, lots of people were saying there's no reason to go multi-cloud. There's just no reason. It adds a layer of complexity. It's not as easy as you think. You can't just take an Azure data engineer and throw them at AWS and hope they'll be successful there. Architect with a purpose. But now we fast forward these 5 years, and I'd say a ton of organizations are multi-cloud, but not so much because they architected it that way, but because they bought a solution, and that solution now runs in AWS. This is one of my clients right now. They're 100% Azure, but they acquired a software as a service. Now, under the covers, it runs on AWS, and because we're buying software as a service, it really shouldn't matter where it's running. But all the things that we're used to doing for, working with the technology, working with the vendor, we keep using Azure terms, and we have to realize that they're using AWS terms. And it's not, a huge obstacle. It's just a little bit of cost, a little bit of risk. The other reason why organizations end up in multi-cloud is because through these acquisitions or because they had a hot-shot consultant came in who convinced management that using RDS on AWS was the only way to do this successfully, that doing it with Google or Oracle or Azure was going to be 100% failure. So they went ahead and they built a custom solution using all infrastructure platform as a service in AWS, and now they're going to try to now manage all this in a completely different cloud provider. I would say that while that was done on purpose, it wasn't architected that way on purpose. It was just a business decision based on what I would call unconfirmed cost, benefit, and risk. Not sure if that's ever happened to you guys. Also in the olden days, we called this 19th hole acquisition. That was contracts that got signed or decisions that were made in the lounge after playing 18 holes of golf. The other important thing is always be costing, benefiting, and risking. So one of the trade-offs with the cloud, and I love the cloud, is that things change in the cloud, like every day. Every day they change. The names change, the brand change, the cost change, the features change. And the cloud providers are doing a great job of not making breaking changes that often. But it means that doing this repeated assessment of, is this the right thing we're doing? Are we paying the right amount of money? Is our storage in the right storage tier? So that's one of the things I forgot to mention in the differences. So yeah, on-prem, we might have had hot storage for our databases and our current systems, and we might have had archived data, for 7+-year-old financial data. But pretty much most of our data was just in a storage server somewhere that we could get to at any time. Well, now in the cloud, you can use sophisticated algorithms and tools to help you pay the right amount of money for storage so that you can put things in hot storage, cool storage, cold storage, frigid storage. Now there are 5 levels of storage, with the coldest being the cheapest, but also expensive if you end up accessing it more often than you thought you would. So always do cost, benefiting, and risking. That doesn't mean be risky. It means doing risk assessments. The other thing to remember is data gravity. Data movement is costly in the cloud, especially for egress or moving between regions. You pay extra for that. And if you're used to architecting data solutions in an on-prem environment where everything is already bought and paid for, you have to rethink those processes. And that's especially true where I see people building multi-cloud solutions, because it's cheaper to do this one thing in AWS than it is in Azure. But now you've really ramped up the cost because data has to leave the cloud in order to get to the other clouds. And people forget to cost the egress of data when to them it's all one system. And remember that all the cloud providers have done a really good job having cost calculators where you could kind of see at a ballpark based on your workloads, your volume, your compute needs. But those cost calculators don't include all those other things that I put about skill sets, tools, techniques, and procedures on the how much slide. This is a really contentious thing that I set firmly here. If you're going to have purposely architected multi-cloud environments, you're going to want or need multi-cloud management tools and expertise. Sure, you can manage all these things with a bunch of scripts that someone shared on their blog and you guys have developed, but you're going to want professional tools here. Remember, you need to engineer out all thematic choices. We talked about fanboys and girls in this one. You have to know which of your current tools work with the new providers and solutions. You should know that before a decision is made. This is not a comparison I made. I'm just going to say all security is complex. We'll just stop there. But it's even more complex with multi-cloud, hybrid cloud, and on-premises in your mix. Building models do change architectures. Again, if you're used to being a data architect in a world where you didn't have to worry much about costs, in the cloud world, you're going to have someone looking at your costs regularly. And the last pro tip is love your data so it will love you back, because the data you support deserves your love. That's keeping it secure, making sure it's performing well, that it has good data integrity and quality. So that's all I had for the presentation. Did we have any questions?
We do have a couple of questions. Let's just jump right into them. Is it really cloud if you just move your VM from an on-prem data center to a cloud one?
I think yes, it is, because you have to meet all those clouds. That's a really great question. It's kind of like how many angels can dance on the head of a pin. Yes, it's still cloud, but it's probably one of the easiest cloud migrations to make if your VM contains everything and you're managing it, but it's still cloud.
Okay. Here's a more general one. What do you think? Won't we all be working from the cloud eventually? Or will there still be some on-prem?
I don't think in my lifetime everyone will be all cloud. I do see this as huge writing on the wall. I mean, of course, this is all dependent on billing models and cost models and regulation and trust. But for sure, I personally am already working much more in the cloud I mean, even my personal life, where my emails with software as a service, like I used to run an Exchange server here. I'm not going to do that anymore. I think that more things will be implemented using as-a-service technologies, and whether you think that means it's cloud or just private cloud, I think that's the big thing, is that everyone eventually will be working with many more things as a service.
Okay, great. Do you have any good places where our audience can get some resources about the data skills needed for multi-cloud and hybrid cloud projects?
I do. So my big place, I went from traditional learning where we got sent off to courses. I'm still a big fan of those, but most learning happens these days by, I think, a lot of vendor documentation and tutorials, like the things I've learned with Microsoft Learn or the Azure tutorials, workgroups. And the fact, the other great thing about the cloud that I forgot to mention is that, you know, if I wanted to learn a new DBMS in 1990, I couldn't just go download a developer copy and start playing with it. Like, I had to have a client, and, you know, if you were a single professional, you weren't going to get Oracle to give you an evaluation license at that time. And now we have all these developer versions and everything, but the best thing about cloud is that the cloud providers provide a certain level of free cloud services that you can use to learn these things. I know Azure has like 25 free services that you get for an entire year for free, and you can learn Cosmos DB and Azure SQL DB and Databricks and Windows, and like that to me is brilliant, because now I can go learn things that I wouldn't even have tried because I don't want to go through all the installation hacks and getting it to work and configuring. I can just fire something up.
Okay, yeah, that sounds like a great resource. Looks like we have time for just one more question. What if we have no control over where solutions are deployed?
Yeah, so that's taking the traditional IT infrastructure model and trying to do it on the cloud. And the best thing I've done is that I can contribute to our infrastructure people who are also the cloud architects. I can say, like, look, here are some things that are highly tailored and optimized for, in my case, database uses. So I want us to do that. And because it doesn't involve buying a whole new rack and new hardware, quite often they're willing to work with me on the data side, whereas in the past, because they had to manage the infinite levels of detail, they're like, no, we just have one standard, go. So I think that's good.
Okay, looks like that's all the time we have. Thanks again, Karen.
Thank you so much. I hope to continue this discussion on Twitter.
Everyone, stay tuned. We're going to take a short break and be back at the top of the hour for our second session of the day, Top Data Security Best Practices for Hybrid Multi-Cloud. Take a chance to check out those resources on your console provided by Red Hat, CoreView, and Cloudera, and we'll be right back.
Hi, everyone. Welcome to the Multi-Cloud and Hybrid Cloud Data Summit. This webcast was organized by the hardworking folks at Virtualization and Cloud Review and sponsored by open source enterprise solutions provider Red Hat, Microsoft 365 management platform provider CoreView, and hybrid cloud data platform provider Cloudera. I'm John K. Waters, Editor-in-Chief in the Converge 360 group of 1105 Media, and I'll be your moderator for our second information-packed session. But before we get started, I wanted to offer a couple of quick reminders here. Each of today's sessions is being recorded for later access. Keep an eye out for an email with a link to that recording. It'll be coming your way within the next few days. Also, this session will be followed by a 5 to 10 minute Q&A. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you. We'll do our best to get to all of them. You might have noticed that our sponsors have provided some extra resources that can be found on the right-hand side of your screen. Please take a moment to check those out. And at the end of the third session, one lucky attendee will be receiving a pair of Ray-Ban Stories, the new Wayfarer-style smart glasses from Meta. This version of these iconic glasses are equipped with dual HD cameras, microphones, and discrete open-ear speakers. You can make calls, listen to music, take photos and videos on the fly, but you must be present to win, so stick with us. Now let's get started with our second session, Top Data Security Best Practices for Hybrid / Multi-Cloud. For this session, we called on Joey D'Antoni, Principal Consultant at Denny Cherry & Associates Consulting, with more than 2 decades of experience at Fortune 500 companies, as well as expert certifications from Microsoft and VMware. Mr. D'Antoni is a well-known thought leader in cross-platform IT. He worked extensively on database platforms and cloud technologies, and he has a special expertise in performance tuning, infrastructure, and disaster recovery. You are in for a great session. Take it away, Joey.
Thanks, Sean. And hi, everyone, and welcome to today's session. Cloud introduces a whole another set of things we have to think about security-wise. A lot of the same best practices apply, and we'll talk about where they do, that you have to think about in an on-premises world. But we have so much that changes, and we have so many tools that make things easier, and at the same time, we have so many tools that make it so very easy to shoot oneself in the foot, or in some cases, blow your entire leg off. If you review various breach data, or I wrote this really interesting or kind of fun article, I guess, for Redmond last year or 2 years ago now about various data breaches that have happened and how they happened and why they were so bad. It's really kind of overwhelming when you start to think about it. And the first bullet that I have here, I think, is one that I like to talk about. And I find, even though I'm deeply a technology professional, I'm looking at my screen right now, and my other screen has a terminal screen with some bash shell code running a Docker container. So, like, I do deep tech work on a day-to-day basis. And I simply say technical stuff is important, but your process is far more important. A lot of what we try to do around security, and really even data, and so much of this kind of ties in to governance. In the middle of this webinar, I'm actually teaching a cost management class to a major company. And likewise, cost management in the cloud and security all really tie back to governance. So it's understanding what the needs of a given application are, what the business processes for that given application, and knowing what data is stored in that application can help us provide the attention to secure things in a timely manner, efficiently, because we only have so many resources, right? That's really ultimately one of the problems we have. And cloud is a little bit of a force multiplier in that some things are automated for us that we used to kind of have to do as a manual process. A good example of this is encrypting data at rest. Even though encrypting data at rest in the cloud doesn't necessarily buy us a whole lot of security other than checking an audit checkbox, it is like a single click thing that used to be something you'd have to generate certificates for. It would be a little bit painful. So it's important to do the right technical stuff, and the cloud makes that easier. It's also really important to not do the bad stuff, and the cloud will sometimes warn you about that and sometimes not. And we'll talk about some of those minefields that you want to avoid. And one of the things about multi-cloud that can make things so hard is, do you really know where all of your data is and what data is there? And this is something that I find really challenging because a lot of organizations don't go multi-cloud organically. And what I mean by that is that if you have multi-cloud, the first thing I'm going to tell you is multi-cloud is something that's really challenging from a whole variety of perspectives: technical, security, governance, money. All of those things are hard, but it's definitely doable. There are organizations we've worked with that have done it in a successful fashion. If you think about your applications correctly and deploy things in a proper manner, it's not that bad. But the way a lot of organizations end up in a multi-cloud scenario isn't that there was a plan where we wanted to have disaster recovery in AWS while we wanted to have primary in Azure or GCP or vice versa. It's that we acquired a company. That company is in Azure, and our primary data centers, or our primary resources, are all in Google Cloud. So now, if we don't retain all of the staff in the company, which frequently doesn't happen when you're doing an acquisition like that, you have to either learn how to manage Azure in a hurry and learn what those vulnerabilities are, and then understand what that company you're acquiring data is, or quickly figure out a migration path. And neither of those solutions are easy. So understanding where your critical data is really lets you focus on building those security models and tuning those down, locking those down, auditing those kinds of systems. That's really to me, one of the most, why I say this process stuff and governance stuff is so important. Because if you just kind of haphazardly do things, and the other part of that is if you're not deploying things in a consistent manner, like if you have different development teams using a wide variety of services, that can also be a challenge, because the broader your service footprint in the cloud, the more you have to know about each of those services. And like various services have their own security. I guess like pitfall is a good term, where like you can screw up. The classic example that everybody likes to use is Amazon S3 buckets. You can leave them open to the public, and then anybody can access your data. I never really understood how that happened so much, because Amazon's pretty careful about warning you about it. But two things really happened. In the past, they weren't so careful about warning you, so a lot of buckets were deployed before anybody knew. A lot of developers realized how bad of a practice that was. And the second was I ran into a security issue, trying to connect to a bucket that I had on a private network. And when that happened, for the sake of expediency in the project I was doing, I made the bucket public, because in my case, it was sample data from Microsoft that I was exposing to the internet. It wasn't any real data. But you can see how those things can happen. And that's where it's important to have, and you don't necessarily want to say you can't use these services, but you want to have a good understanding as an architect of like the services that your cloud teams are using in order to deploy, so you can have a better understanding of the security that needs to take place around them. Another thing to understand is the security model of your services. And this varies a lot, and I want to talk through this. And this graphic is from Microsoft, but I'd like to talk through this in the context of patching software, or what you would have to patch, in kind of what some organizations see as the benefit of using solutions that reduce the amount of stack that you have to manage. So if we start from the right, we see in our on-prem solution, I'm going to use the example of Spectre and Meltdown, which was a speculative execution patch that affected, I think, all Intel processors, and it was announced in around January of 2018. If you were an on-prem organization and you were made aware of these vulnerabilities, you had to patch the BIOS on any physical servers you had. Presumably, you were running some sort of virtualization solution like Hyper-V or VMware. You had to patch the hypervisor. So on all of those servers, you had to patch the base hypervisor. Then you had to patch all of your guest operating systems. And potentially, you had to patch software running on top of those guest operating systems. I know SQL Server and Oracle both had patches, and I'm sure other solutions did as well. If you're running an IaaS VM in Azure or AWS, I can really only speak to Azure because I didn't have any AWS clients at the time. But Microsoft sent an email the night after the patch was the bug was released, and what that email said was, we patched your VMs to address, or we had patched the host that your VMs are running on to address these critical vulnerabilities. Sorry, we rebooted your VM at 2 a.m. Since you're running VMs, though, you are still responsible for patching the guest operating system and any software on top of it. And this is really kind of a key delineation here between IaaS solutions. I think somebody asked in the last session, is moving your workloads to cloud VMs really the cloud? And I think it is. it is mainly because you still have to think about the security aspects. You have to think about the storage and the networking and all those things that are going to be different in the cloud world. But the main differences to me in PaaS and IaaS, and really these are the more common cloud solutions that we think of when we think of cloud, is that in PaaS solutions, which are platform as a service, so this can be anything from database as a service to website as a service to storage services and things like that. The cloud provider generally, and your mileage may vary, and it does very much depend on the service and the cloud provider, but there's really three things they take care of. First, the services are always designed to be highly available and will tolerate nominal failure. It's not like you have a single VM running your solution. There's some kind of high availability built into that solution, so that's something you don't have to worry about. That's also frequently why those solutions cost more, because you're having to pay for that high availability. Second, backups are generally handled. You do always want to ask about, what the backup SLA is and what it's going to look like in terms of how you retrieve that data. But that is something that is generally handled for you. The final aspect of that is patching. When you're running platforms and service offerings, your cloud provider is responsible. You don't typically have direct OS access to any of the machines you're running. So your cloud provider is responsible for taking care of those patches. Finally, with software as a service offerings, so think of things like Salesforce and Office 365, you're mainly responsible for the user security there. Almost everything else is handled by the cloud provider. That still does mean you're responsible for the user security. And like if you look at Office 365 as a security admin, there's a whole bunch of things you can do in Office 365 to better secure your organization, because there's things like email checks that are turned on. Honestly, I wish Microsoft would enable more of those things by default. But if you're someone who's managing email or something like that, you should know those things are still kind of in your scope of responsibility, that you can change policies and things like that. Even though Microsoft's running everything, there's still a lot of settings you can change to better secure your environment. So the other part, and this is probably the most challenging thing, I think, to going multi-cloud, is understanding the security model in each cloud. Let's just assume you're running all VMs, or maybe even you're super modern and you're running everything in Kubernetes. So you're running your multi-cloud environment consists of Azure Kubernetes services and Elastic Kubernetes services from Amazon. But you're just deploying your apps as containers to those clusters. You still have differing models for how the security and identity management work in each of those clouds. And that's something that can be complex to understand. One of the rather interesting things I find is Microsoft. I will say I'm of the opinion that Microsoft has a clear advantage with identity management. I think Azure Active Directory is pretty superior relative to some of the other tools I've used. And you can use Azure Active Directory as an authentication method to actually authenticate into your AWS account. But once you're in AWS, you still have what's known as role-based access control. And role-based access control is how we define cloud security. And this is security to do things within the cloud. For the most part, this is within the cloud control plane. So these are identities, and this can be individuals, it can be service principals or managed service accounts, depending on what they're called, in the cloud, that have permissions to do, or privileges, I should say, to do certain things within the cloud environment. These users need to be defined at the control plane. You really want to understand what the security boundaries are within the cloud. One of the things, like in Azure, you'll run into, in Amazon too, and it's a little bit trickier in Amazon. Amazon people have multiple accounts, which are kind of different than subscriptions. In Azure, similar concept, but they're implemented slightly differently. So it can be hard to get universal security across. I feel like this, once again, this is a place where Azure does something better. But Azure gives us a number of scopes where we can define things. So there's a concept called a management group, which is for organizations that have multiple subscriptions. You might use multiple subscriptions as both security boundaries and billing boundaries because they are tied to a bill. And then within those subscriptions, you have resource groups. In smaller organizations, a resource group is typically going to be the security boundary, and those are defined in Azure as groups of things that are deployed together to support a given application. And you can usually use that as a fairly good security boundary. In some cases, you may want to go down to the individual resource level. But it's important to understand, if you're in a multi-cloud environment, where those boundaries are in each cloud. I just kind of described Azure's model in detail. The models aren't terribly different, and generally speaking, and there are way more roles in this, but there are specific roles for specific resource types. But the three kind of global roles across the clouds are contributor, owner, and reader. Owner can do anything and grant privileges. Contributor can do anything within its security scope. So if I'm contributor into an Azure subscription, I can do anything in any resource group unless there's an explicit deny somewhere that's saying I can't. And then finally, if I'm reader, I can simply see things. I can't change anything. How you're deploying code and your techniques matter. So if you're using automated deployment pipelines, you can run into some challenges here. And I know there are some specifics like weirdness with deployment pipelines and using PowerShell in Azure identities and who can log in. But it's something you want to be aware of, and that's definitely, as you're deploying code or have a CI/CD process that's doing infrastructure as code, it's important to kind of understand how all those things are going to work together, because that's something that can be pretty critical. And then my final bullet point, and you'll hear me talk about this again later in the deck, because it's one of the most important things. MFA. Everybody who's logging into your cloud control plane should be MFA. And if you don't know what that acronym stands for, it's multi-factor authentication. I've even switched to using passwordless authentication for my Azure environments where I can, which is kind of cool. I have a YubiKey that's in my laptop. But multi-factor authentication is not perfect, but it's a lot better than not having it. It does secure you in a lot of ways, even if you think your environment's trusted. There's a lot of cool security toys, and some of the, like Azure Active Directory supports things like privileged identity management. So for example, when I log into Azure, even though I'm a global admin in our subscription, I don't actually have that permission until I activate it. And I have the ability to gate that. So I can make somebody else in our organization approve me requesting global admin, which in some high security organizations does definitely take place. That's why the model is built the way it is. Karen was kind of mentioning this. I came into the end of our session. One of the things you really want to understand is how your tools work. Any monitoring tools that you have, or even security endpoint monitoring tools, how they work across cloud providers, and can they talk to each other. Some of the native tools that both Microsoft and Amazon have are now kind of being designed to be implemented in multi-cloud. Microsoft has a series of products under the Arc branding, and Amazon does under the Outpost branding that can work in either cloud. So you can have kind of to use a way overused term, a single pane of glass where you observe all of your cloud resources in a single cloud vendor, right? So like you can be in the Azure portal and see stuff you have running in Amazon. But knowing how your tools work, I'll talk a little bit more about tools later and the importance of them, because I think it's really hard to run tools to make sure you're not doing stupid things. I think that kind of monitoring is super, super important. And it's also important to understand how your data and applications move across clouds. This is for a couple of reasons. Security is one of them. The other one is cost. A big component multi-cloud cost is going to be that you're going to be paying for data egress from one cloud to the other. So as your data flows out of AWS and into Azure or AWS into GCP, that data is metered and you're paying per kilobyte. So having good networking tools that can help you track the data can help you identify what those data flows look like. The other thing that can help you do, and once again, this is purely cost, is if you can identify some of those data flows from applications, you can maybe work with the application, especially if you own the applications, work with the applications teams to look at including libraries where they're compressing the network code they send, the network traffic they send to reduce your cloud spend. Because anywhere you can compress network traffic going across clouds, you should do it. And you want to monitor your workloads for both security and uptime. I think in recent years, we really, as an industry, harped on this concept of observability, being able to see what's going on without necessarily having to log into prod. So taking advantage of both logging things and having, there are a lot of tools across the environment that do kind of unified logging that let us get better observability and see when incidents are happening. And at the same time, you can use that monitoring to monitor for security. As well as uptime. And as you go multi or hybrid cloud, cataloging your data sources is really more important than ever. And I have a question mark there, and that's just a typo. Sorry about that. I did these slides late the other night. Data catalogs are really, really important. This is something that we're actually working on a data quality project with a new client right now, and it's really challenging, and especially if you're in a growing company or you're in a very large company. I think this is something that needs a lot of work to make happen. But one of the things that a data catalog from a security perspective really helps you with is if you or have a data breach event, you know exactly where your data is, so you know exactly what data was breached in the event that it was breached. So this is something that I think is really, really powerful. I can't remember which company I showed and made note of it, but one of the things that happens with data breaches is GDPR fines. You leak this many EU citizens' data, you have to pay that much money. And somebody was able to greatly reduce the cost of their GDPR fine because they could clearly identify what data was breached. Microsoft is doing a lot of work in this space. They have a feature called Purview that's getting I think the engineering team's doing a good job with it, and it integrates with a lot of data sources, and I really like where they're going with it. And I know there's a couple of other tools in the data catalog space that work to help you identify data sources across your environment. It also kind of leads us into better security models where we can do, instead of role-based access control, we can do like application or even data-based access control, not database, but data-based. Where we can have tags on data and better understand that, and we can do access control that way. And so this lets you identify where your sensitive data lives and how you can protect it. So one of the things that I think just going through this exercise is if you know you're storing unencrypted PII somewhere in a database, and I have sysadmin rights to a lot of databases. I know what you're doing, companies. You are storing a lot of unencrypted PII. It helps you to raise it because it's not just, the DBA who's me yelling that, there's this column of social security numbers and medical information that's completely unencrypted. It shows up on a report. And the better data catalog products also tie back into auditing, so you can see who is accessing that data and help you better understand data exfiltration attacks. This slide is probably, to me, the most important one in the deck, and it's also the hardest to accomplish. This is not something that one person can do. This is something that having a data catalog and data governance project requires organizational intervention. So it kind of really does have to start at the top, because it has to be business driven, because the business is really the only group that knows what the data is. The infrastructure team might have some idea of where the data is, but the business will know what data they're keeping and tracking. And it just gives you a better approach to how you can monitor your data across the environment. You can't just completely tool your way out of this. Like I mentioned, cloud security is a multifaceted process. I see I have a question about, are you referring to Azure Data Catalog? That's the former name. It's called Purview now. I just wanted to catch that. And it's a great intro to this slide. Azure Purview is a nice tool in and of itself, but just like enabling Azure Purview in your Azure subscription isn't going to fix your cloud security problems. There are tools that can help you, and we'll talk a little bit more about these in a second, because I think tooling is a key part of this. It's really a multifaceted process. You have the technical security stuff like identity management and who has access. And yes, I use technical security stuff, loosely defined term there. This is all the stuff that matters, right? Like in separating networks, ensuring that traffic can only talk on the ports you want them to, having firewalls in place. That's all really important. But you also need governance and process to make sure that stuff doesn't get haphazardly implemented. You want to make sure it doesn't, you don't have development teams that are deploying stuff that is insecure suddenly that can maybe access some of that other technical security stuff. So the governance and process pieces there become really important. And when I say process, I mean a few things. I mean, what your development processes are. Are you doing dev security ops or DevSecOps, as it's called, where you're integrating security testing into your development and deployment processes? This also ties into policy, right? You can use policy within your clouds to try to reduce the amount of stupid stuff people can do, quite simply. You can also use policy to better help catalog resources, and this is something in my cost management class I was highly recommending, is that you have a good tagging strategy so that when somebody goes in to look at a cloud resource, they can tell mainly two things. Who's paying, what part of the organization is paying for the resource, and then what part of the, if an admin has to come in when something's down because they got paged, what is the application and what is the impact? Another slight bit of tagging you might want to do is, is there sensitive information in here? Just so you know the security impact of those things. So that's kind of the first three bullets on this slide. And those all kind of work together. And you have to do all three of them really, because it's very easy. The next part is monitoring. And I'll talk a little bit more about this on the next couple of slides. But I think having security tools that can monitor your environment are really good, because you just don't always know what's out there, and things can slip under your policies unless you go crazy with policies, and you really don't want to do that. And then finally, auditing. And auditing really just ties into that monitoring, and it's having people that can validate if any of those bad things happened in the environment. You can't really skip out on any of these and have a good security situation, because they all kind of work together. And I'll illustrate that in the next couple of slides as well, but I hope that kind of makes sense here. So security and deployment policies allow you to control how and what resources are deployed in your cloud. I'll give you a real basic example of something I've implemented at DCAC, much to the annoyance of my colleagues. In Azure, in our Azure subscription, we're Microsoft partners, so we get a bunch of Azure credits. I put in a policy that requires, on the creation of any new resource group, two tags need to be there: client name, client and client name, and then date created. So we have an idea of how old it is and the date that it was created. That's a pretty basic policy. And you can get way more advanced than that. Like I've a training client I work with, they build their own lab environments, and they really want to tightly control costs. So they have policies for each of their labs that students are going to do, so that they can only ever deploy the thing that's specified in the lab. We specified this 2-core, 4 gig of RAM VM in the lab. That is all they can ever deploy. They can't deploy anything else. Those are kind of two extremes. Our policy doesn't really do a whole lot. The other policy does everything. Where you want to land those policies is typically somewhere in the middle. And one kind of approach to this is to build kind of like what we call a service catalog, where you have a set of defined services. You have planned application architectures. This is something that I find is pretty good to do in a larger environment where you have a lot of development teams in an enterprise. You kind of have patterns. So everybody's, even though they're building their own applications, they're implementing in similar patterns, which just makes it easier for you to you have a known thing and you know what the patterns are going to look like, and you know where the security holes are in that patterns. Understanding the impact of the policy is not a blanket fix, but it can help you on a number of levels. It can help contain costs. It can also limit potential exposure. However, one of the kind of interesting things about policy, I've mentioned our little policy at DCAC, is there's no way to, that I'm aware of anyway, at least in Azure, to go ahead and enforce policy on stuff that was already created. So we're about 10% compliant on our policy because we have a lot of stuff that was created before I implemented the policy. So you need to ensure that you're monitoring compliance with your policies. And this can be, you can automate this, or you can have, an intern go yell at people. There'll be a page in your policy page that will show you compliance across all of your resources. And that's something you want to make sure you're paying attention to. Data encryption. It's important to understand what data needs to be encrypted, and moreover, how you can encrypt it and what the different types of encryption are. And this is definitely a multi-cloud thing. I don't think cloud tremendously changes this, except there's maybe a little bit more risk exposure to our data. One of the things the cloud makes very, very easy is encryption at rest. And if you're not familiar with various encryption technologies, encryption at rest is simply effectively encrypting files or hard drives. And in the case of the cloud, it's virtual hard drives. So when we would typically use encryption at rest on a physical server, so I'm old enough to remember racking servers, it would mean that a rogue data center employee couldn't rip the hard drives out of a given computer, go mount them in another server somewhere else that's off the network and less monitored, and dump that data into an Excel spreadsheet. That's what encryption at rest got you, because you would have had to have had the encryption key in order to do that. Likewise, with databases and database backups, both Oracle and Microsoft SQL Server have encryption at rest, and they're both called transparent data encryption. And what this means is the data files and the backups are therefore encrypted. So if you stop the database service and this rogue system admin downloads either the backups or the data files onto a USB drive, that person can't reopen them without the encryption key. So this mainly does a checkbox. It does prevent a little risk because those things are possible, but they're very obvious attacks because they all involve powering down a major service. So it's important. It's kind of obvious when it happens, but it doesn't buy us a whole lot because still anybody who has access to those databases through the front end of the database can still remove all the data from those databases. But the cloud makes this really easy. And the importance of encryption at rest here is it's part of Sarbanes-Oxley. So if you work for a public company, you probably have to do this. And it's literally, well, in most cases in the cloud, it's a default now. And if it's not a default or you have an old thing, it's just a checkbox. It's very easy. You can also bring your own keys to the cloud. This is fine. There's no reason not to bring your keys to the cloud. It's more work to manage because your certificates and stuff can expire, and you have to make sure they're current and backed up. If you don't have this requirement, I typically would recommend using system managed keys. If you have the audit requirement, you have the overhead of managing your own keys, and it's not quite as bad as managing your own keys. There's interfaces within the cloud providers for it, but it's not quite as easy as just relying on the system generated keys from the cloud. The real crux of this, though, is you should really be encrypting your sensitive data within data sources. So I'm a DBA. If I have sysadmin permission in SQL Server, root permission in MySQL or Postgres, or sys permission in Oracle, if there's encrypted data in a table, I can download it to Excel, and there's nothing anybody can do to prevent me doing that, except for some modern encryption features. And one of those is always encrypted in SQL Server. Oracle has something similar. And this is where the data is always stored in an encrypted fashion within the database. So there's no way for even a sysadmin to see unobstructed data. And so this is a really powerful way. But even if you don't have a technology that's that good, you should use some level of encryption within your data sources to encrypt that sensitive data, because even rudimentary encryption efforts will be better than just having unencrypted, personal identifiable information all over the place. And this kind of ties back, and I'm hoping you're kind of seeing where we're tying this all together, but this really ties back into that whole data cataloging thing, right? Because if there's no way, especially in an enterprise, I worked for Comcast, and I don't know how many databases we had. I probably had a total of 8,000 database servers, and you can figure out databases and then tables within that. I had no way of knowing where we had any sensitive customer data or anything like that. So with a catalog, you can better identify those data sources and then treat those particular sensitive tables accordingly. Monitor for vulnerabilities. So this is a building with no doors. I didn't know that the image came through well enough, but one of the things that I think with the cloud, and there are some things that really annoy me that both vendors do by default, and I'm going to yell at Microsoft for a second. If you go through the Azure portal and create a virtual machine, and you accept all the defaults, you get a virtual machine with a public IP address that is open on port 3389 to all IP addresses anywhere in the world. So anyone anywhere in the world can try to RDP and will try to RDP into your database. Even if you're deploying a SQL server, they give you the option to open 1433, which is the port SQL Server runs on, to the world. They warn you about that and say, hey, it's a bad idea. They warn you about the remote desktop thing too, but it's still on by default. Just to give you an idea of like what can happen when you do stupid things like this, Denny, my coworker, and I were bored one afternoon, and we built two Azure SQL Server VMs. We set the SA password to password, and we opened port 1433 to the internet. And both machines were breached within about 20 minutes. They weren't connected to anything, just bogus data on them, but we just wanted to see what would happen. And they were both pwned within 15 to 20 minutes. It was pretty impressive. It's not enough just to have policies and development guidelines, because people can still screw up. Somebody with the best of intentions could be deploying some code, and they could accidentally maybe put something on a public IP address where it's supposed to be a private, or have a flag in a deployment script that deploys something in an insecure fashion. If you're not kind of constantly monitoring for these vulnerabilities in your environment, like from an external source, you're at risk. I mentioned the S3 bucket thing, but that's a really common one. But there are a lot of other vulnerabilities where people put things with Elasticsearch with no password. That's another really common one. So it's important to kind of have those has something that's looking for those vulnerabilities all the time and notifying you. There are a number of tools in this space. You can almost think of this as like ongoing penetration testing, but it's something that I feel like, especially in a larger organization where you have more than a handful of cloud resources, I think this is something that's super important because, as one of my coworkers said, it's really easy not just to shoot yourself in the foot, but to blow your entire leg off and get breached. And like I say, a lot of times this isn't intentional. It's, you can make minor errors in deployment that can lead to pretty big exposure. So the clouds themselves have built-in security tools and scores in a lot of cases. I kind of feel like this tooling is pretty good. I'm usually pretty happy with it. Sometimes, and Microsoft's pretty bad at this, I think Amazon's a little bit more neutral. Microsoft's usually trying to sell you upgraded cloud security in a lot of what they're talking about. But a lot of things will be like, hey, you have this VM and it's not encrypted, or you have this VM and it's got a public IP address and anybody can connect to it. Those things are pretty good. And the scores are pretty good. I kind of went through the process a couple of months ago of I was studying for a security exam, and I dramatically improved the score at DCAC. I think it's worth looking at. A lot of it is a little bit frustrating to me because I kind of wish we just followed best practices and they deployed everything in a best practices format. And some things they do, and they're getting better about doing that, all the providers. But I think these can provide some good insight into what's going on in your environment, and they're definitely worth taking a look at. We can't have any discussion about data in clouds or data in general and not talk about backups. You still need backups in the cloud. Your backup strategy may change. One of the things I do with all of my customers is I don't necessarily back up VMs. We back up data, and we want to ensure that customers have their data backed up. And the reason for that is a lot of times it can be faster to create a new VM and restore the data to the VM than it is to restore the entire VM and get the data in a concurrent state. One of the things you have the ability to do in the cloud that you don't have the ability to do on-prem easily is test your restoration process. You should test restores on a regular basis, even better if you automate it. You need to understand the security model for your backup solution. The reason for this is ransomware. Ransomware, that's one of the first things they do, the common ransomware attacks, is go after VM backups, because VM is probably one of the more commonly used backup solutions. And they try to do a seek and destroy on backups. So understanding the security model for your backup solution, and this ties into my last bullet point on this slide, which is learn the meaning of the word immutable. Immutable means basically write once, read many. So once your backups are written, they should never be modifiable, so that even if they get ransomware, they can't be attacked. Mind your secrets. Don't leave secrets in your code. There are a lot of good tools around this. If you're using Kubernetes, remember secrets in Kubernetes aren't encrypted. They're just base64 encoded. And you can take advantage of hardware security modules that are around for cloud secrets. And then finally, don't ever hard code a password. Yes, you'll have to write 5 lines of code extra, but don't do that. It's just way too risky. Remember when I said MFA? Does anybody remember these? I used to have to carry, right when I started consulting, these were still a thing, and I had 4 of them for clients. Fortunately, now we have mobile authenticator apps, and we have much better ways of doing, although, to be honest, it's a pretty good way of doing MFA still, in my opinion. But we have more secure ways, so things like YubiKeys and stuff like that. If you're not multi-factoring authentication into your cloud environments, figure out how to make that happen and do it, and yell at your boss that they need to do it as well. So 5 tips for secure cloud environments, and this applies for hybrid, multi, or individual cloud. Know where your data lives and who has access to it, because your data is what's valuable. mind your secrets. Don't put passwords in your code. Moreover, be really careful about publishing secrets into like GitHub repos and things like that. Know what your network looks like, so know what's open and what's not. Take advantage of your tools. Have some tools that are constantly monitoring the security of your environment and checking out endpoint management. And the more intelligence those tools have, the better, because the more intelligent the tools are, the more they can act as force multipliers, so you don't have to have a team of employees sifting through logs. And of course, you need to have backups and multi-factor authentication, but you knew that, right? All right. Here's my contact information. If you have any questions, you can hit me up on Twitter. I'm at JDanton. I'm also at joey@dcac.com, and I'm at Redmond Mag and joeydantoni.com. And John, do we have any questions?
We do, Joey. Thank you so much for an awesome presentation. I want to remind everybody that you can still type your questions into the Q&A box at any time. We'll do our best to get to all of them. Remember that we've, if you have a question about a specific slide that's passed or a specific concept, be sure and clarify that in your question. Okay, let's see what we've got here. This one from Vic is, what should we do to protect our backups? That's kind of a basic question.
Yeah, it's definitely a vulnerability. So whoever you're working with in terms of vendors for backups, I think this is a question worth asking them. Ask, how do they protect their backups, and how you should isolate them on your network. If you're using a cloud solution, what should you consider for your cloud? At one point I had a good chance to talk with one of the backup teams at Microsoft about how they secure this, because it's a concern. We just had a concern about kind of an advanced ransomware attack, that methodology that we had thought of, and we wanted to walk through with the backup team how that they would protect against that. And you should be asking those hard questions of your backup vendors. I think that they have a pretty good understanding of the space. I think, when ransomware attacks first started happening, I think they were a little caught off guard. And I think they're all more well prepared now.
Gotcha. Okay. Here's another one from Tori. What protections does the cloud offer in terms of security?
I think, there's a lot of things. I think there's a lot of things that you get in the cloud that in an on-prem world you would have had to have paid for. So some examples of this are, multi-factor authentication is built in. You don't necessarily have to buy anything to do that. Hardware security modules, so places where you can store secrets and reference them in code. Those things are all kind of built in. I think the encryption at rest is something that's good. Like I mentioned, it's not completely useful in terms of everything, but I think at the same time it provides a lot of it provides you that audit benefit. Effectively, what I'm trying to say, and not very effectively, is I think a lot of things that were only available to very large organizations in the past become available to you in the cloud. And I think that's a good thing. You just have to be able to take advantage of them and not make mistakes.
Okay. So we've got a question here from Mark. Awesome for clarifying, Mark. Thank you. Any suggestions when it comes to shifting left and zero trust security measures within the cloud and or hybrid environments?
Yeah. In shifting left, just if you're not familiar, it's kind of ensuring that it's in the DevOps process. It's ensuring that your software meets the design. So moving testing, quality, and performance early in software development rather than later. And I think some of that comes into play with adopting a DevSecOps mindset, where you're integrating security into that early phase of software design, because I think that's something that in the past, I happen to be writing a blog post on this right now, so conveniently, a lot of organizations in the past would they'd build an application and then they'd at the end, the security team would review it, and you end up in a situation where you're like constantly just patching the software then, and you're not really incorporating the security into the design process. So I think getting security folks involved earlier and earlier in the process really helps with that. Zero trust is pretty kind of a different area, but it's zero trust is pretty challenging. I think working with folks that are kind of experts in that space can help you get started, because it's basically authenticating everywhere all the time and not trusting anything. And it's definitely an effective security approach, but it's not easy to implement. And I think it can be pretty broadly misunderstood. And it's probably its own topic.
Okay. Here's another one from Vic. Can you explain the concept of immutability better? So somebody wants some clarification.
Yeah. This is the easiest way to describe this for those of you who are old. Is CD-ROM disk, the original ones, not the rewritable ones. So when we first got CDs, I'm trying to remember. I was in college when we got them, so it was like in the mid '90s. You could only write to a CD. You could never rewrite. We eventually got the fancy CD rewritables. That's an example of a media that is immutable. It can't be overridden. Which the reason why we care about that is what ransomware is going to try to do is encrypt any of your backup files. So keep that in mind. The other thing that is oddly, and this ties into backup heavily, an immutable platform is tape. Tape is write once, read many, and we're really append only. But and as a matter of fact, Microsoft uses tape for their archive storage in the cloud. So those are kind of interesting things. It's a kind of a big concept in backup spaces. So once again, I would talk to your backup vendor to kind of understand what their model around this is.
Okay. Mark has another question I'm going to take. I'm thinking of Azure Security Advanced Center 2B, GitHub Advanced Security 2B, Quantum Resistance Encryption 2B, MFA, 2B Token Security Key.
Something's getting formatted weird there. The Azure Cloud stuff is pretty robust in terms of the information it gives you. And I think I saw Mark had something about bio authentication. And yeah, I think one of the reasons why I switched to using the YubiKey is one of the recent attacks. Well, I think it was the one from the 15-year-olds in London. What they were doing was like somehow they were buying credentials online. So they were buying pairs of credentials from users and for various tech companies. And I don't know how these were captured. But then they'd get 4 or 5 users that were, all in high-level technology roles in a company, and then they just spam the heck out of them with multi-factor authentication requests. The notion being that if you spam a group of people enough times, one of them is going to accidentally click OK or accept or whatever one of the times you do it, and that was the case. The YubiKey, however, it's a physical key that is connected to the workstation and to you. It's basically unphishable. So that was one of the things that led me to start moving in that direction.
Fascinating. Okay, here's one from, let's see here. This is from Victoria. What are some common mistakes that organizations make? Another kind of generic question, but a good one, I think.
I think it's just not. I'm going to go really high level here and not go into too many specifics. I think it's just not dedicating enough resources to planning up front and not thinking about security first. And that actually kind of ties back into Mark's earlier question. Even I'm talking about DevOps in terms of shift left, but even in terms of just planning and deploying things, having that security thought from the beginning. And I tend to see this more in smaller and medium organizations where they don't necessarily have a dedicated security organization, but it is a common mistake. I think it's one of those things where even if you don't have a team, you can start to take advantage of some tools to guide you early in the process. And this will be self-serving, but hiring expert consultants to kind of guide you down the right path is also good, especially if you don't have expertise in the cloud. There's a lot of places you can make mistakes. And, you know, people who do it all the time and across a number of clients can help you, I think, miss some of those mistakes. Especially, like I say, if you're a small organization and you're new to cloud, that's kind of the sweet spot for that.
Well, it looks like that's all the time we have for questions for this session, Joey. Thank you so much.
Thanks.
Okay, brother, take care. Many thanks to Joey D'Antoni, Principal Consultant at Denny Cherry and Associates Consulting, for a really great session, and to our sponsors, Red Hat, CoreView, and Cloudera, for making this summit possible.